Christmas it's been after like.
We've had it one more time, like one more year like that.
When did we get off last? It's a short Christmas break.
Yeah, it's a short Christmas
I think
break.
we got off on the 22nd last year.
Yeah, somewhere
When did we get
around.
off?
Okay, here we go. A ball is thrown upward with an initial velocity of, whoop, try that again. There we go. Velocity, negative? Yeah.
When you drop it.
Yeah, when it's on its way down, then we're negative. Let's try that again. That was getting deflected. Hit it. That was a nice try. Okay, ball's thrown up in the air, initial velocity of 18 meters per second. That means when you release it, 18 meters per second, and then when it's on its way down, it is negative. The height of the ball is modeled by this equation. The height, not the, so the position vertically is equal to 18t minus 4.9 t squared. What is the maximum height that the ball reaches? Well, you guys tell me something about the maximum height. What do you know about the velocity at the maximum height? It's zero, because it changes from positive to negative. So if we want to find the maximum height of the ball, easy. We take the derivative, which is equal to, and we take that and we set it equal to 0. I want to solve that. So I have 18 is equal to 9.8 t. Divide both sides by 9.8. Take out my handy dandy calculator.
I don't think so. The JV just did $1. Just for everybody to get the people on the leave after like the first half. Yeah.
And I get 1.836. So, question B, what is the height of the ball after 2 seconds? What do I do to calculate the height of the ball after 2?
Plug into
Plug into where? Do I plug it into this function or the above function?
the bottom one.
The bottom one is the velocity function. Notice it says what is the height? So I need the height function. H of 2 is equal to 18 times 2 minus 4.9 times 2 squared. So I'm going to go ahead and plug that in. $18 times 2 minus 4.9 times 2 squared. 16.4. Suppose I didn't want to know the height. Suppose I wanted to know the velocity after 2 seconds. Would I plug it into the top one or into the bottom one? The bottom one. The bottom one's the velocity function. So if I want to know the velocity, v of 2 is equal to 18 minus 9.8 times 2. Let's just be smart about it now so we can make sure we assess the reasonableness of the solution. Time 2, is it on its way down or is it on its way up? At time 2, is it on its way down or on its way up? On its way down. It reached its maximum height at 1.8 seconds. So it's on its way down. So if it's on the way down, the velocity should be negative. Let's see if that works out. We have 18 minus 9.8 times 2. And I get negative 1.6. And it looks like meters per second is going to be the label. This height would be meters there. This would be seconds here. Should always attach a label. I'm going to change this one really quick to a different question. I really don't like it. And I'm going to change it to this. What what is the height, or what is the velocity, excuse me, when the height is 10 meters. What is the velocity when the height is 10 meters? So the first thing we have to figure out is when does it reach a height of 10 meters? So I'm going to go ahead and I'm going to plug 10 into H. So 10 is equal to 18t minus 4.9t squared. And notice in this situation that you have a quadratic. If I subtract the 10 over, I get 0 is equal to negative 4.9t squared plus 18t minus 10. Is there anybody here who has the quadratic formula plugged in their calculator from last year? Let's take that out and see if we can make quick use of this. I did repost that on the Google Classroom for you guys in case you could have looked that up. So if I grab Paradise's calculator and I go ahead and press program, it says quad. And I press enter on that. You would have to enter it into yours. And I press enter on the formula. It asks what A is, and A is negative 4.9. Then it asks what B is. B is 18. Then it asks what C is. C is negative 10. And I get 0.68. And I get 2.99. Why did it get two answers?
Because it's a parabola.
Yeah, it's on its way up, it hits 10, and it's on its way down when it hits 10. So the question is not at what time does it reach that height. The question is what is the velocity? In order to figure out the velocity, I would then plug these back into the velocity function. Okay, so we will figure out the velocity at those times. Again, is 18 minus 9.8 times t. So we will calculate those. 18 minus 9.8 times, and what was my first one?
0.68.
0.68. And I get 11.336. If I take 18 minus 9.8 times 2.99, I get basically the same value, don't I? It's just negative. That would make sense, wouldn't it? Okay, so we'll say 11.3 and negative 11.3, just so we're consistent. 11.3 meters per second and negative 11.3 meters per second. Okay. Are you good? So we talked about application the other day with the movement of particle back and forth. We're going to continue to build on that. These are some other neat pieces that you can work with in terms of motion. There's a lot of other applications. I'm going to just isolate these applications just to an economics piece. You guys take economics right now?
Oh, yeah.
Okay. Anybody here doing AP Econ? Just 1, 2, 3. Is that second semester? It's second semester. So the rest of you do all of Econ right now, or some people second semester? Yeah, right now?
There is a second.
Right now? Okay. So you won't necessarily see this piece in Econ right now, but for those of you who might, is anybody here considering being an Econ or business major? Okay. So as you pursue that, without a doubt, they kind of have a few different calculus options for Econ majors. And one is short calc for the Econ majors who can't handle calculus. And then they have the real calculus. Your credit should transfer for this, no problem. But you might see some of your classes actually bring up that calculus idea. Okay, so I'm going to explain to you very, very simply, and it is this. In Econ, sometimes we are given by the way, if you ever come up with a formula in Econ, you're like, where did that come from? Mr. Dunn might not see that with the math background, but I have had multiple people come and say, Mr. Gans, we see this formula, can you show where it comes from, like math-wise? And we're able to show that pretty quickly. So the cost function, we're just going to say C of X. And that is the cost of producing X items. Okay? All right. Now it's here where we gotta get smart. Okay? We're gonna be smart. Here, what do you want to produce? You get to make something. You get to have your business. What would you like to make? She can make food. Okay? Gonna make cakes. She can make cakes in mass bunches. Okay? She's got a really, really good cake recipe. Has different flavors. Built into it. It's got decoration, all that stuff. Okay? All right. How much is it gonna cost you to make your cake?
To make it?
Yeah. We'll say $10. That's $10, okay? Do you think it's going to cost, now pay very, very close attention to what I'm saying, okay? Very important for you to understand this piece. Will it cost her more to make one cake, or will it cost her more to make 10 cakes? 10, right? Okay, wait.
You tried to trick me.
No, I was not. I was trying to be very intentional. So let's now go to where Sam is saying. Will it cost her more to make the first cake, or will it cost her more to make the 10th cake?
First one.
The first one.
Because you haven't made profit yet.
And aren't you just more efficient the more you make? Right? Like it might cost you $10 to make the first cake, but maybe the second one costs you $9. Maybe the next one costs $8.50, right? Every once in a while, I make things for people. I'm kind of a carpenter. And if people want me to make stuff, I'm always like, are there a couple more people I can make one for? I'd rather do 3 at once. You see what I'm saying? Because I'm more efficient that way. So there's something we call the marginal cost function, and that is simply just the derivative, C prime of x. And that's the cost of producing the next item. Okay, so Gilly said the cost of making the first cake is going to be more than the cost of making the 10th cake, right? Mm-hmm. So if we found C prime of 10, that would give us the approximate cost of making the 11th one. And that's what it would tell us. And that's good for a business to know, right? It can tell us about efficiency and everything else. So here we have it. It says a company produces X number of shoes. So this company doesn't want to produce cakes like Kira said. We should have a cake sometime. Let's see, who's bringing in treats next year?
Next year?
Brody, he could bake a cake for us. You can put in your request. You're always allowed to make requests in this class.
You got that?
I do think that there's one more like ice cream sandwich in the freezer. We should probably grab that before it goes too bad. Anyway, company produces X number of shoes. The cost can be estimated by this function there. Okay? So what is the marginal cost function? Marginal cost function is just C prime of X. What is the derivative of 10,000? 0. What's the derivative of 5x? 5. And the derivative of 0.01x squared is going to be 0.02x. Pretty simple, right? Says, what is C prime of 500? So all I'm going to do is I'm going to plug 500 into that. 5 plus 0.02 times 500. We'd like to calculate that. I'll grab my calculator. Or I just remember that 0.02 times 500, I believe, is 10. And 10 plus 5 is 15. Interpret what C prime of 500 means. That means the approximate cost of producing what?
Shoes.
The 500 first pair of shoes. Is $15.
$15 each.
$15 for the 500. Yeah. So yep. So it's not that the cost. If you want to know the cost of producing 500 shoes, just plug in 500 into that. If you notice, you're going to get like, well over 10,000, aren't you? It's going to cost us a lot of money to produce 500 pair of shoes. But the cost of producing the 500 first, only $15. We're pretty efficient. Looks like a lot of startup costs in this company, huh? $10,000 get started right away. Yeah, considerable. So the last question that we have for today, you guys can go to your work then. Compare C prime of 500 with the actual cost of producing 500 first item. So what does that mean? Well, what it means is this. Suppose that the cost of producing 200 items was equal to $103. And suppose that the cost of producing 201 items was $106. Then how much did it actually cost to produce that 200 first item? It cost $3, right? So we're going to find the total cost of 501 items, or find the total cost of 500 items and subtract those to see what the actual cost is. Again, the derivative is an approximation. And the reason why it's an approximation is because you're jumping from integer to integer. You can't produce like 500.5 pair of shoes. You can't produce 500.9 pair of shoes. So let's go to our calculator and type this data in. Best way is to go to y equals and just type in your function, 10,000. And then what is it after that? Plus 5x? And then it's plus 0.01 x squared. Okay, so I've got that. I can go ahead and go to my table, and I'm going to type in two values. I'm going to type in 500. That'll be the cost of producing 500 items, which it says is exactly $15,000. And then we're going to plug in 501. The cost of producing 501 items is, and if you highlight it, you can see $15,015.01. Yes.
It's like stuck in this. How do I get it?
So you're going to go to your table set, and we're going to go down and go to ask. And now you can go ahead and do that. So we're just about done. The cost of producing 501 is $15,015.01. Cost of producing 500 was $15,000. So the actual cost is equal to $15.01, which is about $15. So again, the derivative gives us an estimation, and it is usually a really, really good estimation. Okay, and that's that. So derivatives can be used in many, many fashions. You see a couple right here. We are going to move on to the derivative of sine, cosine, tangent, and all those things later on this next week. So go ahead and take out your